Welcome to episode 16 of Aurei Plays 7 Billion Humans. We managed to make it to phase 4, so let's see what we get there. Ah, cool. Okay. Okay, cool. So you can make a loop over all directions. Okay, interesting. Let's see. Okay. And how are we going to make them? Oh, we can just walk up. I never noticed these kind of things, but you can just walk straight up. Okay. So let's step up. If below is a data cube, or if below is, so if there's no data cube above and below, then we step up. And we repeat, else we're at the inside. So at that point we can do for each deer. Okay, so I guess we for each deer is basically a set, but then for each direction. So then we can calculate mem2 equals mem2 plus mem1, and I guess we need to pick up below first. So we have a data cube to write it on. So when we're done, we write mem2 and we drop. So I guess this should be fine, right? Maybe mem2 is not initialized and that could be an issue. Yeah. No, it looks to be fine. I think this will work. Let's speed it up a little bit. Yeah, that's good. Good user command less speed is fine, so that's good. Let's continue onwards. It's the last phase, but there's a lot to do. Local maximums. Okay. Okay. Okay, so at least we can start with stepping to the left twice. And then we do it for each deer. But so we have all the directions. We store it in memory, so I guess we can also pick up that direction, right? So we can, the easiest way to do it is just make two loops. For the first, so we set memory 1 to 0. Well, it is 0 already, so we don't need to do that. So we set mem2 to that item if mem2 is larger or equal than mem1. Then we update mem2. Oh, I guess we don't need to make 2 loops, right? Because mem. Okay, so it's kind of. So I think mem2 contains a location. So after the loop, we can just do pick up mem2. That's after the loop, and then walk to the shredder. I think this should be fine. If it's not, then we need to do another loop and another comparison or something. But I think this will actually, this seems like it works. Give to mem. Nothing to pick up. Okay. Let's see. If mem2 is greater equal mem, I did the inversion here incorrectly, right? Yeah. So if mem2 is smaller than mem1, then we update. Let's do smaller equal, because then a 0 would get used. Yeah, there we go. Awesome. Cool. We got the size challenge. That's pretty awesome. And also the speed challenge. Neighborly sweeper. Okay. Ah, cool. Okay. Awesome. Okay. Your if command says data cubes only if they're on the floor. You try to query a tile that contains a worker. Oh, okay, cool. Okay. This is a good thing to keep track of, because indeed, like either... Wait, why is there a 63 there? Okay, that's just to prevent us using 0 as a detection mechanism. The total number of cubes, okay. Yeah, so we can't really... This is kind of questionable. Yeah, so I guess what we can do is we can check, hey, if there's a worker on there, just to wait until the worker moves off. It's kind of annoying, but it'll have to do. So let's see. So let's say, let's detect if to the left is a wall. Set mem1 to 1. So if mem1 is 0, we walk left. If mem1 is 1, then we walk right. I mean, we could duplicate the program as well. So we're not getting the speed challenge at this point. Let's see. So yeah, okay, let's say if mem1 is 0, then we step left, else we step right, and then we do something. So if we're standing on a cube, is a data cube, then we're gonna do for each direction as mem2. It's fine. If mem2 equals a data cube, then we set mem3 equal to, or we calc mem3 equal to mem3 plus 1. We do need to set mem3 here because we're going to be reusing it over the time of the program. So let's see. We want to. So if it's a data cube, we want to add. If the mem2 direction is a worker, we want to just keep checking. Else, if it's not a data cube, then we can just continue in the for loop, right? So we fall through, we go to the next direction. Yeah, so this is everything we do when we have a data cube. Then after the for, we pick up that cube. And then we write. And what do we write? We write mem3. And then we drop it, and then we jump back to here. Okay, let's see. Oh, here's something wonky going on. Why is he adding 0 to stuff? Oh, I did mem1 here. That's not correct. We need to have 1, right? Yeah. Okay. Oh, so funny. So that would actually work for everyone who is, because we set mem1 to 1. Everyone who's walking right is doing it correctly, and everyone who's walking left is not. Okay, this will take a while. I don't really have a way to see if this mechanism works other than waiting it out and seeing what's at the end. So let's just assume that it works and fast forward. Yeah, awesome. Okay, pretty close to the size challenge, and we got the speed challenge. That's nice. Cool. Okay, that's it for episode 16. Thank you for watching, and I'll see you next time.